Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Muhammad Talib, and today, inshallah, I will present two important RF measurements that I have conducted in the lab. The first experiment is measuring antenna reflection coefficient using a vector network analyzer, and the second is generating and analyzing RF signals using a signal generator and a spectrum analyzer. Experiment 1 VNA S11. In the first experiment, we used a VNA to measure the S11 parameter of two antennas. S11 represents the reflection coefficient at the antenna input port. It tells us how much of the incident power is reflected back due to impedance mismatch. A lower S11 means better power transfer to the antenna. Before any measurements, we performed one port calibration using open, short, and load standards. Calibration is very important because it removes systematic errors from the cables and connectors, ensuring accurate results. After conducting the antenna to port 1, we measured S11 in dB over the frequency range. From the graph we identified the resultant frequency where S11 is minimum, the S11 value at resonance, and the bandwidth where S11 is below minus 10 dB, which is the standard for good matching. If the antenna is not matched, most of the power will be reflected back, reducing radiation efficiency and potentially damaging the transmitter. The experiment 2 signal generator spectrum analyzer. In the second experiment, we used a signal generator to produce a sine wave at a suitable frequency with output of minus 10 dBm. We then conducted to a spectrum analyzer to observe the signal frequency and amplitude. Using markers, we measured the peak frequency and power level. Then we verified the output power to minus 20 dBm and minus 5 dBm and 0 dBm, and observed the changes on the spectrum analyzer. We also changed the frequency to see the shift in the spectrum display. This helped us understand how the spectrum analyzer visualizes signal characteristics. We must always be careful not to exceed the maximum input power of the spectrum analyzer, and we start with low power to protect the instrument. In conclusion, these two experiments give us hands-on experience with essential RF measurements tools. We learned how to measure antenna matching using S11 and how to generate and analyze RF signals. We also understood the importance of calibration, impedance matching, and instrument limitations. Based on our results, we can now judge whether an antenna is well matched and suitable for its intended frequency band. Thank you for watching.